I think everyone has just about joined this webinar, so we can get started with it. So hello and welcome to this webinar, this functional regression testing webinar. Just so you know, after this session, a copy of this will be uploaded onto our Ten10 website, so if you did miss any of it, it is free to download afterwards. This webinar will walk through how to create and execute an efficient regression testing approach, and we're going to be touching on some different software development models and approaches that can typically be taken as well. Just by way of introduction then, I'm Charlotte Hayes and I'm a principal consultant here at Ten10. I manage a digital testing lab based from the Leeds office. The digital testing lab provides solutions for clients who are maybe developing a new application or upgrade to support business growth and require some functional testing or some compatibility testing. Some companies may have a requirement to meet some industry regulations and require some accessibility testing from us. We also conduct regression testing for those companies who need to ensure existing applications will continue to work as expected for new releases across devices, browsers and operating systems. The agenda for today's regression testing webinar, we're going to take a look at what regression testing is, how does it work, why is regression testing so important. We will look at how regression testing can add value to a company. We're also going to walk through some ideas of how to create an effective testing approach, and lastly some thoughts and key takeaways from the session. These next slides I'll be walking through what regression testing is and when it is used within a project. I thought I'd start this session off by giving a bit of a definition of what regression testing is, and then also give a bit of an analogy of what I found that was really interesting for regression testing. So, regression testing is defined as a type of software testing that confirms a recent program or code change has not adversely affected existing features. Regression testing is a full or partial selection of already executed test cases which are re-executed to ensure existing functionality is working as expected. Regression testing is often an afterthought in companies or deprioritised as it's not thought to be important enough to spend money on and time doing, but this presents potentially damaging product quality risk if not conducted. Although many companies may have a suite of regression tests, is the suite still effective at identifying potential issues, or how can you make your regression testing packs more efficient? We'll go into this in a little bit more detail in the further slides. This next slide shows my analogy between regression testing and maintenance work or MOT work if you put your car into a garage. So consider your intentions when you take your car into the garage for an MOT or some maintenance work. You probably want it done in the most reasonable amount of time and the mechanic to only do what's required. Outside of the required work, you only really care that the rest of the car is operating within the acceptable tolerances. Beyond that, you aren't really too concerned about what the mechanic is telling you. Things seem to be working fine before, why suddenly would these things be wrong now? When you receive information back on recommended fixes, it raises a few undesirable considerations. Is the work necessary to do? Is the car still safe? How long will it take? What if they find something else? How much will all this cost? Even if the information is valid, you aren't really open to hearing it. In fact, it may cause you to question the quality of both previous work and the current information. No one would take their car to a mechanic if they knew with certainty that the car would function perfectly without it. Similarly, sometimes companies can see regression testing as just a just-in-case activity. Bugs are not expected, but it's not worth the risk of skipping it entirely. Any issues raised during the regression testing will trigger the same fears you get with bad news from the mechanic about your car. What if you find other issues? How long will it take? How much will it cost? Is the scope of testing necessary? There is now risk and uncertainty where we didn't expect any. How did it happen? Was it working fine before? Should we fix this? Why didn't we catch it sooner? How does this impact the schedule? The quality overall of the product comes into question. Software maintenance is an activity which includes enhancements, error corrections, optimization and even removal of existing features. These modifications may cause a system to work incorrectly. Therefore, regression testing becomes a necessity. We look to regression tests when there is a change to the following. Change in recent requirements and the code has been modified. We would typically look to execute a targeted regression suite around these specific changes within the system. This allows for a risk-based approach to testing, so we are not charging any unnecessary costs for tests that aren't required. When there is a new feature to be added in the software, this could potentially be a broader set of regression tests but still targeted around the new feature to ensure a wide coverage. New environment configuration. It may be beneficial to conduct a full regression suite as the environmental changes could impact the whole system or function. You may of course know the specific area of change where it could impact the system, therefore a smaller set of tests could be run. Defect fixing or retesting. We would retest these defects and as part of those areas execute a broad range of tests across those areas to ensure nothing else has been impacted within those areas. Performance issue fix. Validating where the performance issue is, whether it has impacted the whole system or just one area, and then compile some appropriate tests to run. Using a risk-based approach for running a regression pack allows for cost and time efficiencies within the project. When you are thinking of executing some regression suites, think about how to find the right balance of test coverage and how to manage the tests within your project. This little diagram shows specifically when you're regression testing, these are some of the key areas you can think about before you're starting. So retesting all. This is one of the methods for regression testing in which all tests in the existing test bucket or suite should be re-executed. This is a very expensive way to do it and it requires huge time and resources to undertake, so it should be used rarely unless the whole system has been impacted by a change and there is a need to run the entire pack. So you can also do a regression test selection. Instead of re-executing the entire suite, it is better to select part of a test suite to be run. Test cases selected can be categorized as reusable test cases or obsolete test cases. Prioritization of test cases, so prioritize the test cases depending on the business impact, critical and frequency used functionalities. Selection of test cases based on priority will be greatly reduced the regression suite pack. These next slides will highlight the importance of regression testing and how automating the pack could be more efficient. So why is regression testing important? I thought I'd add a little deal bit here to show that it is important. So when you fix one bug, you could potentially introducing several newer bugs. Now we'll go through why regression testing is so important to run and not just be an afterthought. So it mitigates risk. Using a risk-based approach, we can save time and efforts on regression testing by choosing test cases to cover the application areas affected by recent changes in the project and ranking them according to the priority. The risk to deploying to the live environment is significantly less than not having run any regression tests at all. So the next one is we maximise test coverage, so you can avoid reputational risk by ensuring you have appropriate level of regression testing completed against your product. A good number of defects reported by customers were due to a last-minute bug fixes, creating side effects and hence selecting specific test cases for regression testing, but it's not always that easy. Effective regression tests could be selected by looking at test cases which have had previously frequent defects or looking at functionalities which are more visible to the users and pick out some key tests. You could also look at some test cases which verify core features of the product, or look at test cases of functionality which has undergone more and recent changes. Look at integration test cases or more complex test cases that have previously been run. There's also boundary value test cases, successful and failure test cases, which might be something to think about. Target testing. So targeted testing, the common problems when regression testing is that you can select too many tests, which makes the pack lengthy and costly, and you can also not add enough tests to cover the app or system, which leaves higher risk of finding it in live. You could be adding out of date tests that aren't testing the correct functionality, ensuring that you know your product and are targeting the correct areas within your system. It can be cost effective. Regression testing is an important part of the software development cycle. It can be also very expensive with the time and cost efforts it involves and some of the budget limits. If bugs are identified in live, it could block a product from being used, so we'll need to have the right balance of cost versus product quality. This provides information regarding the quality, so provides information to the stakeholders so they can make an informed decision as to whether the product is ready to be put live or whether further testing is required. In this slide, we will cover using an automated regression suite to speed up your regression testing and deliver some efficiencies. Running test packs manually allows us to create a broad coverage, but the testing can take a while to execute, so automating those regression scripts that are good candidates allow the pack to be run fully and repeatedly after every release or change can speed up the time to delivery and return on investment. Some of the benefits for automating your regression suites are reducing human error. Automation can ensure that the right things at the right level at the right time are completed by using automation for predefined repeatable tests that greatly improves the accuracy and consistency and auditability of your testing and reduces the risk of costly human error. Automation is not only about the extent of test coverage. However detailed and effective, test scripts need regular maintenance, and it is recommended to review them after each major release to add new scripts covering new features and delete outdated test scripts. Scale testing without increasing costs. As already mentioned, if the majority of the regression tests have been automated, then it is really easy to scale up those tests and run them against multiple devices and browsers without incurring extra weeks of resource effort. Automation can be run overnight or after work and can be interrogated and results documented without incurring lots of project costs. For each project, you have to look at the desire to increase test coverage by increasing the variations of input values, or a manual test as a high number of input values and/or process flows. Then that effort to automate the scripts, the complexity of initial creation, and the maintenance of overhead. Long-term savings. Having repeatable automated tests greatly improves the accuracy, consistency and audibility of your testing. These tests can be run quickly without lots of cost and resource effort. Automation can ensure maximum return on investment delivered through the right balance of test and technology capabilities, irrespective of whether you've chosen software development life cycle as waterfall, agile or even a hybrid approach. So working efficiently with continuous integration. Ensuring appropriate levels of regression testing is a significant challenge within agile delivery environments, with time pressures leading to limited regression testing execution and focus. This is exacerbated by automation regression test depth, with agile teams often lacking the time and budget and skills to implement and maintain automated regression tests with focus on new functionality and areas of change. Continuous integration is less expensive than not integrating continuously. If you don't allow a continuous approach, you'll have longer periods between integrations, and this makes it more difficult to find and fix problems. Such integration problems can easily knock a project off its schedule or cause it to fail altogether. Continuous integration can bring multiple benefits to a company. It increases visibility and enables better communication within teams, can catch issues early and resolve them before they become real issues. You can build a solid foundation and reduce the amount of integration problems, allowing you to deliver software more rapidly. This picture highlights the approach that Ten10 would take to making a regression suite automated. This is a repeatable process and maintains the test suites for all future releases of a product or a system. So here you can see you start by automation candidate, so making sure the tests are a good candidate for automation, because not all test scripts can be automated. The script preparation, so step-by-step scripting, could be BDD format, could be any format, just ensuring that automation runs correctly. Goes into the automation backlog once it has been scripted correctly, and then also is picked out into an automation script and into the framework maintenance, which is therefore the script is maintained here, and then we conduct a smoke test or a regression test, and this is a continuous process which carries on after every new release and future releases, so we can go back and regression test. This means that the tests don't become out of date and they all are valid tests to run. This next slide gives you some ideas about how to create and work towards an efficient regression testing approach. How to create an efficient regression testing approach. As a product grows and becomes more complex, the coverage of regression testing increases. This can be problematic if we're not careful. It can become so large to run that it could have a negative impact on delivery times, but we want to continue to regression test to a satisfactory level. So how do we avoid this but still ensure that we can keep on top of potential regression issues? The whole project team should take ownership and work together to create an effective regression testing strategy. How do we structure our project, waterfall or agile, design our team, or how often developers push code to an environment where everyone's code is integrated can affect regression testing? It's also important to think about and look at a team's maturity, the culture and development approach, and assess how that might impact your regression testing approach. The structure of your team and how they develop software has an impact when you carry out regression testing. Below, some areas that affect the way in which a regression suite could be approached. Let's talk about some software development life cycles and how these two approaches differ. The waterfall approach. If you have a project or team that are working in a phased waterfall approach, it's likely you'll be given distinct releases to test. As each of these releases comes through, you'll have new features to test and older features to regression test. Because there is typically little communication between developers and testers in a waterfall approach, testers are compelled to run full regression suites because they don't know what has changed and hasn't changed since the previous release. The traditional waterfall approach tends to have a lengthier regression suite to run, but has full coverage of the system under test. This does mean that the project will need extra time to execute the tests, whether it be manual or automated. An agile approach. If your team is taking an iterative agile approach, a good agile team is looking to get something released and in front of a user as soon as possible to get feedback and to adapt it. This means smaller, more regular releases or changes to run regression testing against. For example, if you follow continuous integration, then regression testing will be carried out each time a developer pushes some new code and new build is created. The collaborative nature of an agile team means testers should be more informed of what has changed and to be able to determine what regression testing to carry out. However, this requires the whole team to take responsibility for regression testing and not only the testers. The short release cycles in agile environments can create challenges for testers. To avoid becoming a bottleneck, test cases must be ready to execute as soon as coding completes on a user story. But this may be difficult if there is a lack of documentation at the beginning of the sprint. This the team may feel that it's caught between the proverbial rock and a hard place. Delaying the testing in a subsequent sprint incurs technical debt that the team may have to pay later, while performing only limited testing increases the risk that defects will make it into production. There are some things you can do to maximise quality assurance within the limited time available in an agile life cycle. You can create a task in the sprint to automate the tests selected for regression testing from the previous development iteration. Complete this task early in the sprint. Your team might already be doing this, but you have developers creating automated unit tests for your new code. You can also build time into the sprint for manual exploratory testing of the stories in the current sprint. Test each story as development finishes. Don't wait till the end of the sprint. Apply risk-based prioritization to manage the size of the regression test suite. Use a continuous integration server to run unit and integration tests for each build of the application. It is not necessary to run the entire regression suite for each build, but do run it at a meaningful interval so you can get good coverage. Make sure that your definition of done includes the software changes that have passed all regression tests. How to create your test suites is dependent on how you test as a team. Here below are several different approaches for your team structure. So, scripted, or as an approach 1, if you're working on a test team that favours test cases over exploratory testing, it is likely that you will have your scripted tests stored in a tool which continuously grows as you create more test scripts for new features. The explicitness of test scripts means it's easy to pick out which to run during a regression testing session, but requires constant reviewing and maintaining, ensuring that your test scripts are relevant and reflect the current behaviour of your product. This means removing test scripts that don't match with the product anymore and updating others to remain relevant. You can also have some exploratory test sessions. If your team favours exploratory testing, then you may have a stored list of charters, test sessions and notes that you refer to during regression testing. An exploratory testing session using previous session notes can guide testers enough, but also still free to catch some bugs that test scripts might miss. However, they require more skill and understanding of what has been tested so far to help determine what sessions to execute. Another area is automated versus manual regression testing. As mentioned in some previous slides, regression testing tests are good candidates for automation. They are executed often and are relatively stable, especially when compared to new test cases. Automating your regression testing suite makes it possible to test overnight and in parallel, and tests can be run automatically for each build at the application under test by a continuous integration server. In short, automating your regression tests enables far greater code coverage at a lower cost than would be possible with strictly manual regression testing. Regression test scripts are developed on the basis of repeatable and effective manual test cases that detect bugs. So in the beginning, a testing team would have to perform manual regression testing to ensure the application system was stable enough, and then automation of regression testing makes sense when a project has reached some level of maturity and no longer experiences roller coaster changes or business logic changes. So by now everyone should have gotten some useful insight into regression testing and how it can be implemented successfully and efficiently. The next slides will go through some key takeaways and some handy tips. Finally, here are some good practice and key takeaways and handy tips for you if you're thinking about implementing a regression testing approach, or just some handy tips on regression testing. Hopefully these areas help. Have a good regression testing strategy in place before testing. Having a test strategy encourages you to target your testing towards areas of the product that are more at risk of changing than others. Instead of exhaustively testing every part of the product again and again and again, When you release a new version, a well-designed product, your team can measure which of your products are more at risk of change than others, and other parts may have been untouched by the new code. So regression testing is something that requires careful consideration. So you need some upfront planning between you and the rest of the team to give clarity and visibility of your regression testing approach. Ask questions about the product and the project and learn to work and search for ways to improve yourself and your team. Then you will be successful. A team that collaborates and communicates well about regression risk can make regression testing smoother. It doesn't need to be a drain on your resources, but rather a really great tool in your testing toolkit. Maintain the regression suite. Whether it be automated or manual test suite, this has to be maintained and updated regularly. The tests are only as good as the test written, so if there are any out-of-date scripts or scripts that fall foul due to a change of functionality, then these scripts need to be reviewed and either amended or removed to ensure an efficient test approach is run, especially around targeted areas. After each release, these scripts need to be merged into an existing pack and updated. Consider product quality versus cost. So using a risk-based approach can save time and efforts on testing by choosing test cases covering the application areas affected by sort of recent changes in the project and ranking them accordingly to the priority. The risk to deploying to the live environment is significantly less than the cost of not having run any regression tests at all. So regression testing is an important part of the software development lifecycle. It can also be very expensive with the time and effort costs it involves, maybe pushing out the budget limits. But if bugs are identified in live, it could block a product from being used. So we have to make sure we have the right balance of cost versus product quality. Automate only the right things at the right level at the right time. This is something we like to promote here at Ten10. We automate the right things at the right level at the right time by using automation for predefined repeatable tests. We can greatly improve the accuracy, consistency and audibility of the testing and reduce the risks of costly human error. Our automation factory approach here at Ten10 ensures that the development lifecycle we will identify which test scripts are suitable for automation and then typically define a blend of automation alongside some exploratory manual testing, ensuring the best value and the greatest return on investment. We will also provide you with advice and guidance on tool selection, test environments, test data, maintenance of the test scripts and the management of devices to guide you through the process. So we've come to the end of the webinar now, and I hope you have found this really useful and might use some of the key takeaways for your project. We're just about out of time now, so if you do have any questions then please send an email and contact us using the contact details on the next slide. Thank you very much for joining. Bye.